You want to go next? Okay, then we do how to make coffee as a 20-minute lesson followed by 10 minutes of questions and discussions, and then we do clothes folding for 20 minutes followed by 10 minutes.
So I get the boring topic and they get the interesting topics.
Exactly, yeah.
Okay, so this boring topic was given to me by Jim at the start of the semester. I didn't know what I was going to say till about 2 days ago. So I have taught these courses for a long time, so this does reflect many years of experience, but the words I'm going to use are just 2 days new or old. So let me start by asking you guys, what do you expect? You've got the title, Project Courses. There's of course some details I'll talk about, but abstractly, what do you expect me to say? What kinds of things you expect me to say? So I'm talking more about the structure. And I asked this question for 3 reasons. First, maybe I can adapt. I do have prepared slides, so there's only limited amount of adaptation I can do. But mostly I want you to think abstractly about how a lecture should be structured. And you guys are privileged enough to have courses like this. I never had a course like this, which means I didn't really learn the stuff that you guys have learned. So there's, I'm sure, a lot I can learn from you based on the course. So somebody want to? Yeah.
Well, sure. I would expect that at the start you would sort of describe what a project course is and how it's different than a normal course. I assume there's projects involved, but
So
I don't know how many projects it takes to make a project course.
good. So I should define the scope of my talk.
Yeah.
Okay. So that's one thing you said. You said something. Oh, what you said besides definition, you said something else also that I like. I forgot.
I was saying, I don't know how many courses it takes to make a project.
So that's definition. And so that's, I can define it and I can leave it at definition. Would that be enough?
It'd be helpful to give an example of maybe of a course you've taught.
Okay, so to make the definition clear, I should give an example. Okay, example is always good. So that's still explaining the scope.
Talk about how to structure a project, what kind of projects are feasible, what kind of projects are not feasible.
Okay, so what kind of courses might be amenable to projects?
Yeah.
I mean, there's
and also what kind of projects are amenable to certain kinds of courses, right? Because like a graduate course, you might have an open-ended project. The compilers class, for example, is very step-by-step closed project where there's a certain answer.
So define project, classify project.
Yeah.
Okay.
Sure.
What did you say again?
Give an example.
So that's define, example, classify, good. I'm not doing all these things, by the way. So, like I said, I'm learning. Other things you might expect. So I can leave it at that. And you said, then what kind of? Once I've classified, there was some actionable item you wanted me to also. Some. It was
sort of the other way around. You said it was like what courses are good for projects.
What kind of course? So what kind of projects there are? And then what kind of courses are good for projects?
Like the matching problem.
Yeah.
Which is like
So
design the course on the project on the course.
Okay, good. Anything else? So, but what did you learn about teaching from that? Sure, you learned that these courses can go to these, have these projects mapped, but you didn't really learn anything, right? So what do you want to learn from this? This is good. If you don't want to learn anything, I have an easier task.
There's a project. What's the role of lecture in the class?
Okay, so let's abstract that. How does a course change when you have projects? And one of those dimensions are what kind of lecture to have, right? And you guys have all, we'll see what the project is, but you probably have all taken some project course. Anything else? So lecture is one aspect of teaching. What else? What are other aspects of teaching that you have to worry about? That you guys are worrying about in this course? Yeah.
Another one, I guess, is sort of like the content of the course, because it can sort of, you have to teach students enough so that they can do the project, and the project has to be interesting.
Okay. So what are the properties of engaging projects?
Yeah.
Right. And doable also, perhaps. That's as instructors, that's something you don't really care about, right? Anything else? So lecturing. What else takes time in Has Jim told you what the most interesting part of teaching is? And I use interesting in quotes here. What he hates the most? This is when I feel it's a job. He said, I never feel it's a job till. What?
Probably grading.
Grading. So maybe that's an issue. Anybody has been a TA in a project, what you think is a project course? How enjoyable is it being a TA? Why do you shake your hand? Shake your head?
Oh, no, I TA'd an undergrad class once that was a project course, and because it was a project course, there wasn't like a simple rubric, so you actually had to spend the time going through everybody's project. And it was terrible.
It was terrible.
And then all the students,
They'll-
because they knew what they were going for, and we didn't necessarily, they would come and argue why their project fit whatever, did what it did. At least it was like a very basic level project, but.
So maybe office hours and TA duties are also an important issue here? Okay, so anything else? Okay, let's see. So I should define what a project is, okay? And what impact it has on teaching activities. It could be lecture, TA, etc. And maybe there are some techniques and tools. I mean, yes, it was terrible for him. Maybe I can tell you some words of wisdom that won't make it terrible for him next time, right? So these words of wisdom can be techniques, or we can think of some tools too. I mean, we are computer scientists. We want to automate things, and it'll be good to automate ourselves away. And if I'm going to talk of techniques and tools, I should have some basis for defending them. It shouldn't be just religion or words of wisdom that you just have to believe. So I need some principles and data also. Okay. So let's start with examples. You liked examples, so I don't want definition. I like proof by example. That's easy, right? I mean, Jim Anderson won't like that, but I'm a systems guy. I can do that. So tell me something here that's definitely not a project, something that's definitely a project, and something you don't know.
First is what?
What is not a project?
The first one?
Compute the product of two numbers. Okay. Somebody want to tell me what's definitely a project?
The fifth one.
1, 2, 3, 4. Assemble a device. Okay. So we are not just talking computer science projects here. Project is a more generic term, right? And something that's a maybe. Yeah.
So classifying a species, because it could be something that's really simple, like you just look it up, or it could be a species that people don't really know how to classify, and then it becomes interesting.
Okay, so if it's a research, it becomes interesting,
Yeah.
and if it's not research, it's boring. So I'm kind of getting what the definition of a project is. If it's interesting, it's a project, and if it's not interesting, it's not a project.
I mean, I guess you could probably argue, right, that compute the product of two numbers. Well, if it's like logic design, you have to build a basic computer that's going to do it, then it's a project. But
So we computer scientists love indirection.
yeah.
So what you're saying is, rather than just using a calculator, let's build and rather using this computer, let's build a computer, which of course will fail, and we'll probably get 2 + 2 = 3, but you'll feel more satisfied and it'll be more interesting, right? But why did you think that multiplying two numbers is not a project and assembling a device is a project?
So usually the first one is too trivial, or
It's too trivial.
yeah.
So what is trivial? So what about composing a theorem proof?
Yeah. So projects also usually involves real life stuff.
That's interesting. So I mean, Jim will find this interesting, I'm sure. Composing a theorem. Some of you guys who are brainwashed by him also might like it. and it's interesting. I think you guys know very well it's not trivial. Okay, but you're saying it's not real world, perhaps, especially when Jim teaches this stuff, right? But so we are getting to some properties. Interesting, that's subjective, right? Trivial, yeah, maybe that it shouldn't be, but real world is now that's also within quotes. Okay, but at least we have some. It's a little less ambiguous than saying. Anybody else want to qualify what a project is? I'm trying to figure out a definition here. Yeah.
I feel like it'd be something that is moving beyond a basic set of instructions. So most of these could be not a project if you're just following the instructions you're given. But I think if you have to advance those instructions to something that you weren't told how to do, that would make a difference.
So, research, not told what to do, creativity,
Yeah.
right? So when there's creativity, there's some, maybe there's more than one solution also there? Because if there was only, a prescribed set of steps, well, you still have to create, but maybe there's more than one solution also, because it's real world problem. Real world problems have more than one solution. So we I think, getting to some properties of project. Somebody else want to?
I mean, even if we have to do something somebody told us, I mean, for example, if we reproduce the papers,
Sorry, say that again.
if we wanna, reproduce some paper,
Reproduce a paper?
yeah, there could be a project, but it's not something about the creativity because we are going to just reproduce. But
So if I lecture and you take down notes, that's not a project because you're just prescribing. It's just prescribed, right? But if you interpret it and make a depressy out of it, condense it, maybe that's a project. Is that what you're saying?
I mean, what I'm trying to say is that, for example, you are, reproduce some other people's the results.
Right.
For example, the paper, then it doesn't require us to have some creativity.
Right.
Some maybe have to put a lot of efforts to make it work.
Right. So
Then there could be,
do you think that's a project or not a project?
I think it's a project.
Okay, so I mean, it's interesting. So that's my classification, and I just realized, this is great to have discussion. And Jim told me not to have more than a certain number of slides, so clearly he was right. But you're trying to create some artifact, okay? And I'm assuming that even composing a theorem is a project, okay? The theorem might have to do with, something that will prevent you from. It might be the halting problem. Okay, and it might prevent you from doing security analysis and thinking you can get it right in security, because the halting problem prevents most security stuff from working. So you're creating some virtual or physical artifact. It's a real world problem within quotes. More than one solution to the problem typically. Okay, and you're doing this not in some fake world. You're using industrial strength too. Okay, so if you're teaching programming, you're not using a Blue Jay environment that just has that's meant to be simple for students. You're maybe using Eclipse, which is what the real world people use. Okay, and based on how real world it is, you can talk of degree of project. Okay, and if you just Google project-based learning, you'll find a lot of links. So this is actually a technical definition I've got from a paper I've referenced. Okay, so that's what. So at least we know, we have some idea of what a project is. We've got the examples also. Now it's interesting. I went from the examples to the definition. I could have gone from definition to the examples. Anybody know the formal terms for doing it one way or the other? Never mind. Which?
That's not the induction deduction thing, right?
Inductive, deductive. Okay. So where did you hear about this?
Fred presented it on the first day.
Oh, fantastic, fantastic.
But Fred never said what they were.
I'll tell you
left
what.
the class hanging.
Deduction comes from the evidence, right? And then induction's the other way around, or do I have it backwards?
Okay, well, so examples to definition would be, what do you think, inductive or deductive? Inductive? Okay. So, Fred told you the pros and cons of inductive versus deductive? No? What do you guys prefer, inductive or deductive? I took the inductive approach. I clearly prefer that. What do you guys think?
Situational.
Situational. That's as a systems guy, that's a very good answer. Okay, it always depends. There's trade-offs. Okay. Anybody says no, inductive always? So what is the advantage of deductive? Yeah.
I think if you know the principles or the rules, then of course you can do deductive. Most of the time when we have to think about something, and that means we don't know the answer, then we have to derive it from the example.
So if you're doing research, maybe it has to be inductive. right?
Yeah, or based
Because
on
you don't know what you have. You have examples, you're abstracting, and you're saying, okay, but when I'm teaching, but if I already know the result as a teacher, but you don't know, so for you it's new, for me it's old. So should I make you go through the research step and induce it, or should I do it deductively?
I feel like inductive can be somewhat constraining when you're learning a topic for the first time, because you end up learning the examples you learned, and you find a lot of times, I don't know, I find I have this inability to see past those examples and, expand further, especially when you have like classes where they give you certain ways of doing things, certain examples of types of problems, then the test of very different ones. And
So you're saying inductive is good or deductive is good then?
I think that you need a harmony between the two. Inductive is maybe a good way to introduce, but
deductive is.
I feel like I don't know. It's definitely certainly good exercise to do deductive reasoning.
So you think, or you mean deductive reasoning,
Deductive.
going from
Deductive, going from the definition back to
the examples.
because that, I don't know, there's kind of, it forces you to synthesize the information better.
Okay. So, good. This is debate here. Since there's debate, there should be a paper written. And the general feeling is that inductive sticks. Okay, if you derived it yourself, think about how many of you guys, like me, like mystery novels better than just regular. You'd write. In mystery, you confuse the hell out of the reader. You give them the wrong clues, and the reader is working with the writer to solve the problem. Okay, when you're giving how to do this, how to win friends, succeed in life, you just get a bunch of rules, and you learn them and you forget them perhaps. But the mystery probably you don't forget. Okay, you know why the birds came in, or why the shower scene was scary. So I personally think every talk should be a mystery novel. Okay? And which means that you have to help make the person solve the problem with you. And if you give the solution away, they're just applying an idea. That's so boring. Why is deriving it? Especially if you get into research. Okay? So inductive sticks, okay? Inductive is extremely hard. Okay? And so most teachers don't use inductive, is what this paper says at least. I got from NC State. Students in first year schools like inductive, according to him. And students in third year, second year can't deal with inductive. Okay? So that's what's kind of going on here. So if the answer is depends, it depends on the student, depends on how much time you have. But having taught for a long time, inductive is hard. Okay?
When we do research, it's almost always inductive.
Research has to. Yeah, exactly.
Because we fiddle around with examples.
Exactly.
To get intuition and then try to figure out what are the fundamental.
So that's the point. Does the classroom mirror what happens in research? Mm-hmm. Or is the classroom a nice sanitized version of what happened? You don't tell all the hurdles you faced and you say, here's a nice beautiful solution, and people say, wow, rather than going through the deductive makes the lecture look very good, by the way. Very smooth progress, everything is so nice, neat.
So we're having a conversation. So the thing you said about the mystery novel really resonates with me. We were having a conversation just yesterday about how to craft a paper that we have to submit in a month. And when we got to the meaty section of the paper, I was telling the student, I want this to come across in phases where they get comfort with the first phase, and then you sort of establish a quandary. And they're like, that is not so easy. And then you resolve it. So it's like you create tension, you resolve. You create tension. You
Absolutely,
resolve.
and it's music to my ears to see a theoretician like you say that in the presence of Sanjoy, another theoretician, because we systems guys, when our solutions come out, they are so damn simple, they say that's obvious. So we have to go and show that why it was hard. But you guys write a paper on P-FAIR, and then you write a paper P-FAIR made easy. And if you're going to make that P-FAIR made easy a mystery, you're going to make it hard, right?
This is actually a systems paper, but yeah.
Okay. so I feel that we guys whose solutions ultimately are simple, we need to use inductive in a research also. Okay. So now I have 10 minutes left. Given that there is degree of projectness, which do you think is the maximum projectness in all of these things? I'm going to claim that proving a theorem is also a project.
Compilers.
Compilers. and
Software engineering.
software engineering. Why? Why?
You cannot learn compilers unless you build one.
I actually, I took this compiler course as a senior, and I had senioritis, like, I don't want to do any work. So I actually didn't build a compiler. Okay, but I took a compiler course properly. Excellent. So,
It's like I watch Bob Ross paint, but I can't paint. You don't know who Bob Ross is? He's the fuzzy-haired guy who paints on yes.
okay. So, compilers, we all use a programming language. A programming language needs a compiler. If you build a compiler, it has a real-world problem, for sure. Okay? You probably use real-world tools also, like Yak and Lex, and you have these cumulative assignments that you did throughout the semester to build a compiler. And in software engineering course, that's what happens also. Okay? So these two courses are probably the most maximum, is a maximum. And compilers in software engineering can be taught without projects. Okay? I mean, you can teach them theoretically, you can take, and you can show the algorithms and hope it all sticks. Okay? And as Jim is saying, that's a stupid way of doing compilers, but it can be done. Okay? And so project-based learning is a principle easier applied to certain courses. Going back to what Mark said, that what kind of courses are amenable to projects. Well, if the course is about real world, it's easy to have projects there. Okay? Now, cumulative assignments. I could teach a compiler course by just saying, hey, let's start this, at the start of the course I say, you've got a compiler due at the end of the course, and we'll do a demo at the end, and I'll teach you in the meantime. Or I could say, here, Lex's scanner's due at, within 2 weeks, and parser's due 4 weeks from then, and so forth. So why cumulative? I mean, it's intuitive, right? People do cumulative, but can we formalize why cumulative? Yeah.
I think a big thing is that if it's a new topic, it's difficult for students to sort of know how long each part takes. So it's good to kind of lay it out.
Pace,
Yeah.
right?
Because not they might wait till the last 2 weeks to write a compiler and then
And
they
order,
don't turn it
right?
in.
And order too, right?
Did you say might? Who? Is there anybody here who will not wait till the last 2 weeks? Okay, that's one good reason, that to pace themselves, force people, have a stick.
But
And
pieces are less intimidating than the whole.
pieces are less intimidating than the whole. Again, divide and conquer. Okay. Any other reason?
That applies to dissertations too. Sitting down to write a chapter is easier than thinking about, I gotta write this whole dang thing.
And that's why Jim insists on so many papers before dissertation, right? So that there is incremental results. So, when I went to school in India, I was going to this American system, IITs, where there is semester of systems. My brother had such a great life as an academic. He went to sort of a liberal arts school there. And he studied 2 days before the final, and he aced the university. And I studied every week. I had an exam. Okay, and why did I feel good about suffering? There's distributing the work, there's distributing the feedback, and there is this thing about distributed learning is more effective than massed learning. Okay, so when you spread it out, you're getting feedback incrementally. You are pacing yourself, and that is a principle that defends my way of having learned. And you can apply this to a great level, to fine grain level, but at the very least it means that you have multiple assignments other than one project. Okay? And this principle is behind a lot of the new techniques that you hear today. It also means that while doing an assignment, if you have an automatic or human tutor giving you feedback, that's going to improve learning. And there's a guy, Jeff Green, who's a professor in teaching here, and his advisor, Roger I got his spelling wrong. I thought I copied. Okay. Zevedo is at NC State, and they've written this paper on why this incremental feedback works. And you guys might have heard of Kelly Hogan from Chris Jordan. She's a biology teacher here, and she talks about active learning and how you should, in a lecture, also be doing work and getting feedback from your peers. Okay. So this is all trying to apply the same principle of distributed learning being better than massed learning. Okay?
You gonna talk about cheating?
I might. Okay. These guys didn't say they want to know about cheating in the beginning. Teaching. Okay.
Because that's a problem if everybody's learning together.
Ah, okay. Yeah, I've got 6 minutes. I'll be mindful of the time, and so I just want to say that these are principles, okay? And project-based learning is a principle. Yes, in compilers you expect a project, but you could teach a compiler course without project. Inductive learning, distributed learning, and distributed learning implies all these other things, okay? So this is really a very fundamental principle to keep in mind, okay? It's all nice to have these principles. You know, when you guys did your software engineering course, there were all these principles, and when you guys actually program, they all go out of, you abandon them. Why? Because you want a deadline tomorrow, and you're just going to get it working quick and dirty. So, time is a big factor. Students have limited time. You have limited time. So you have to, yes, you can go and have all these, have all these principles, but you've got to go and weigh against this. So there's trade-offs, and I think from Fred's talk was about teaching being a design thing. So whenever you design something, there are trade-offs to be made, and so, there's trade-offs. Okay. So the question is, the fact that you have projects, and we're going to focus on programming projects because we're in the computer science department, and these principles are independent of the fact, independent of whether the course is computer science or not computer science, whether it's project-based or not project-based. Okay? Well, the top one is project-based, but the other ones are independent. So when you compose the project-based principle with the other principles, and then you focus on computer science, is it easier or harder to make these trade-offs? Or let's just put it another way. What is special about so let's take composing a lecture. That was a project that two of you are going to have been involved in. That's a project. Creating a software program is a project. What's the difference? Easier, harder? Let's just 5 minutes to focus on this, but
We need to go a few minutes over. It's
then I take time from these guys. I don't want to do that.
okay. We don't have a faculty meeting pushing us out of this room, so we won't 5 minutes over this.
Okay. So what do you guys think? Does the fact, and you kind of indicated that, when you were a TA for a programming course, things were bad, right? So is there something about programming that makes things different and special and interesting and hard?
Well, in this exact comparison between lecture and software, the end requirements are, I guess, sort of more vague in a lecture than in software. In software, it's much more easy to verify when it's done and correct. Maybe unless it's a user interface sort of project.
Or this time.
Yeah, something like that. But
So it's easier to figure out whether something had met the requirements or not.
yeah, I guess so.
And who knows that that's good or bad from a teaching point of view. That's good. Anything else?
Well, that gives you instant gratification. You know you won.
You also know when you don't win and you have to go to the office hours.
Yeah.
Otherwise, you just say, okay, it's done because I've declared it to be done. So, so that's good. Anything else so programs can be manipulated with other programs more easily. And easier to tell if they're right. Okay. So what you have can be manipulated with other programs. Okay. Which is interesting. Then you can create tools for teaching, perhaps. Okay. So these are the two properties. We don't know what impact they have. So Jim, how much time are you giving me?
How much time do you need?
No. How much time are you giving me?
Go to 5 after.
Okay.
Easily.
Okay, fine. Okay. So we've got a definition. We kind of know what the difference is at least. I've given you some principles. So the question is, in another 6 minutes, what techniques and tools can I talk about? Okay. And there's a bunch. So let's talk of this cheating kind of thing. So here's a quiz question that I can give to my students. And the question is, size of an array can change dynamically during program execution. Okay? And I'm kind of indicating that students might be confused. So by the way, those of you who are fresh with the Java knowledge, the answer true or false? You guys are taking time. It can't change, right? So why might students be confused about the answer?
There's a billion words.
Because there's a billion words? You don't like reading?
Not that much.
Okay. Well, these extra words, believe me, help get the right answer rather than prevent the right answer. But why might students be confused about arrays being dynamically sized in Java at least? You guys are such, you've forgotten, right? What makes a good teacher is empathy, which means you've got to be a little stupid to teach well, because otherwise, if you're so smart, then you're above everybody else, and you don't understand what problems people are having. Well, you've got this variable. People confuse the variable and the object. They tend to associate them together. So when you go and say assignment scores equals this, and then say assignment scores equals this, you say, oh, the array changed. It's got a new size. Okay, and this is a problem that students will have. Dom, do you remember this when we did 401? Okay. So how can we resolve this confusion? Okay. But what Kelly Hogan says is that after you had the quiz and you got the answer wrong, you have a phase where you all sit together and you sit next to the person. You ask the person next to you, what answer did you have? And then you infect each other with your reasonings. Okay? So you have another person tell you, because these things are easy to grade, they're true, false, they don't require any explanation. So they don't give you the feedback you really need to understand. So the feedback you get is from a human being sitting next to you. Okay? That's a general technique that she applies to biology, and you can apply to any field, including computer science. But since this is a computer science course, can I do better than that? The fact that this has to do with a programming problem. Can I do better? The person giving me feedback is another human being. Can the thing giving me feedback be a program? So, if you were to understand Newton's laws, you can go and experiment, right, and see, at least inductively, get there. Well, you can experiment with the program. And by the way, honest, not project learning. So I developed this technique last semester, so this is very fresh, okay? Where what they do is they take a program I've written and investigate it. Okay, they put breakpoints, they go and look at the debugger screen, and they go and actually see the array in memory. They go and see the variable being assigned another array, but they know that the array has this particular ID, so that array's size hasn't changed. The variable now points to another array. So they go through this investigative technique to figure out the answer. And they go through this, and then I ask them, okay, is the size of an array, can it change or not? Can it change? Okay? So they do the exercise on here, and they do the Sakai quiz on the right, and they do this discovery-based thing. And here, it's all hands-off. I'm not there. I've got the script. I've got the formula to discover. Okay? They just apply the formula. Okay? I'm not saying this is the right thing to do. I'm just saying this is a possible thing to do because we've got it. And it happens, this is something I can do here because I'm trying to teach an abstraction in the programming language. And the compiler and runtime will allow me to explore the abstraction. So if the teaching is about abstractions that are in the programming language, then the language can provide you with the answers if you just provide them with the path. Okay? So that's something different you can do. So debugger and program output provide some answers learned inductively. Okay? And this is, again, they're learning through example here. They take the example, they see the stuff, and then they go and abstract it out. Okay? So they play the role of a collaborator in previous case. And, they learn that they can get answers to abstraction questions by trying it out. I remember there was this time when I had this question about C++. I'd never programmed in C++, so I asked everybody the answer. And then I asked Sanjoy the answer. Sanjoy, C++, what does he know about programming? And he knew the answer. I was so impressed, but I was still unconvinced. It was Sanjoy, right? So I wasn't sure. Then I asked a grad student, and he said, let's try it out. I said, what a novel idea. So I didn't have a C, and we tried it out, and we got the answer. So trying it out is, teaching a person to fish, right? So this is project-based learning. And it's an alternative to lecture, not a step after it. Okay, so this is important. When Kevin comes and talks to you, he'll talk about how the students watch the videos first, then they solve problems in class. Here also they're solving a problem in class, kind of, right? But it's different. When I tried his approach, my students just weren't watching the lectures. I mean, I gave them projects that keep them really busy throughout, so they don't have that extra 3 hours to go and watch my video and then take the quiz. So I said, okay, forget about my videos, just go and learn this way. So this is an alternative, that you don't need to have seen a lecture to do this, you just can follow the instructions along. Okay? And I also have recorded lectures, okay? And they can be inductive, and they are, they have pictures, they have diagrams. So it's, I'm not saying that's the best alternative. This is also a good alternative. Okay? It's another, it is an alternative, the other one. And pictures worth 1,000 words or something. I can't draw pictures in those praxis. So, but this is not project-based learning. So what I've been doing last semester is that their deliverables are assignments, cumulative assignments. It's harder in a course like 401 to have cumulative assignments because I don't have this compiler or some well-defined object that can be incrementally done. I have these quizzes, and they can use, there's the deliverables, they can use the recorded lecture or praxis as learning means, either both or one or none. And there's a question then, I really should wrap up.
So what, in the interest of time, why don't we go ahead and have the first student set up, and while they're setting up, you can make the last few points you want to make.
So, yeah, sure, I'll just make the last few points.
I don't know, who's going first?
He is, and he's going to be making, look next to you.
Okay, guys, here's the lesson, what I want to say. I talked to Jim and I said, so how's your class? And how interested are they? And he said, you know what? Most of them don't want to teach. And I said, why? And he said, they think it's the same, they want creativity, and teaching the same thing again and again and again is such a boring thing. What I want to say is that A, there is no correct way of doing things. It's a design activity, so there's trade-offs. Okay? And B, because there's trade-offs, you don't quite get it. You have to try again and again. You have to decide what trade-offs you're comfortable with. So just as designing a stupid iPhone user interface is a big deal. Okay, it's a very simple thing compared to teaching P-Fair. Okay, and yet it takes so much time to get it right. To the edges be rounded. Should you see everything in one screen, multiple screens? That's stupid compared to all these these esoteric stuff we guys do. If that is a hard activity as design, this is really hard. And what keeps me interested and alive is that every time I find some problems that I want to solve the next time, and I create new problems, of course, and it's challenging at least. Okay? I'm not saying one gets it right. So that's what I want to leave you with. That there's and computer science is fun because you can build tools. And because it's hard, and if we can have self-driving Uber cars, we can have self-teaching tools also. So as a researcher, it's interesting. As a teacher, it's interesting. And I better get out of here.
Right here.
Wow, you have exactly the right number of chairs, huh?
We will kick
This
is not our...
I know.
You should stay for a preview of what you'll experience next year when you teach this.
I'm staying.